Dear guests, colleagues, and industry stakeholders, welcome. Today we gather to address the blending want of our global food system, which is simultaneously the most exciting fight for engineering optimization, food waste. I am a legislation strategist with a PhD in food engineering. That means I spent half my day wrestling with the laws of thermodynamics and the other half deciphering the complex paragraph of EU regulations. And the concept of zero waste only brings to mind colorful recycling bins. I'm here to surprise you. The central thesis of today's presentation is this. Preventing food waste has evolved from an ethical aspiration into a hard engineering and data management problem for the HORECA sector. Just as the bridge will collapse if you miscalculate its static, the food system collapses if you miscalculate cold chain parameters or inventory turnover rates. The only difference is that when a bridge falls, it makes noise. When the food system falls, 1.3 billion tons of food rots silently, and we call it shrinkage. In this presentation, we will see that the EU Green Deal's famous farm-to-fork strategy is not just a political text, but a technical manifesto that will change even the operating principle of your kitchen fridge. We will discuss where Turkey stands in the national compliance process, the legal surprises awaiting us in 2025 and beyond, and most importantly, how we can turn this process into an operational excellence opportunity. This course is examined to transition from a linear food production model to a circular economy framework grounded in the polluter pays principle and regulatory accountability. It integrates advanced preservation technologies, digital waste tracking systems, and global case studies to translate circular economy theory into measurable progress toward the 2030 50% food waste reduction target. You can see our learning objective. The objectives develop regulatory literacy, engineering competence, and digital integration skills within a circular economy framework. Participants will be able to translate legislation into operational practice, apply advanced preservations and measurement technologies, and design economically viable waste reduction strategies aligned with the 2030 targets. And we can say again, zero waste is not a choice but a necessity requiring engineering and data management. There is a rule in engineering. You cannot solve a problem you cannot define. Our goal is clear: to reduce per capita food waste at retail and consumer levels by 50% by 2030. I did not set this goal, UN Sustainable Development Goal 12.3 did, and the EU is swinging it over our heads like a legislative sledgehammer. So how will this 50% reduction happen? By simply asking our chefs to please be a bit more careful. Certainly not. The traditional take, make, dispose linear economy has reached its biological and economic limits. The solution lies in integrating circular economy principle into kitchen operations. But I am not talking about romantic environmentalism here. I'm talking about sensor measuring ethylene levels in your cold storage, AI cameras looking inside your trash bins, and algorithm optimizing your menu based on the weather forecast. In short, I'm talking about transforming the kitchen into a science lab. The critical success factor of this transformation is to wear legal regulations like Turkey's zero waste regulation, not as a bureaucratic burden, but as a lever that eliminated inefficiency. A hotel manager recently told me waste management is costly. I replied, what is truly costly is the tenderloin you purchased, store it, staff it to process, and then throw it in the trash without earning a cent. Preventing waste provides direct improvement in operational expense. Now let's look at the economic mathematics of this. In economics, there is a concept called externality. If the polluter does not pay the price for polluting the environment, but society does, there is a market failure. The polluter pays principle exists precisely to correct this error. And the most ruthless yet fair application of this principle in the field is the pay-as-you-throw system. Imagine if your electricity bill was a flat rate, would you turn off the lights at home? Probably not. Currently, in many municipalities in Turkey, solid waste tax is indexed to water bills or is fixed. So, whether you throw away 1 ton or 100 kilos, you pay the same. The pay-as-you-throw system changed this. When we examine applications in Germany and Benelux countries, we see digital scales and RFID locks on waste containers. The system recognizes you, weighs your waste, and bills you accordingly. The beauty of the system is if your business separates organic waste from other waste, you pay a very low or zero fee for it. But if you say, I can't be bothered, I will mix everything, then you pay a serious price based on the mixed waste tariff. This is the most effective motivation for your finance manager to knock on your door and say, chefs, let's separate this waste or our profits are melting away. Municipalities in Turkey will accelerate the transition to this infrastructure after 2025. Those who are prepared will win. Let's get into the biochemistry a bit. Food spoilage is essentially a war against time involving oxidation, microbial growth, and enzymatic reactions. Our strongest weapon in this war is modified atmosphere packaging technology. Modified atmosphere packaging involves taking the ambient air inside the package and replacing it with a specially designed gas cocktail. For example, if you want to maintain the right red color of red meat, paradoxically, you need high oxygen because myoglobin needs to convert to oxymyoglobin. But that same oxygen feeds bacteria. This is where 20 to 30% carbon dioxide come in, acting as a bacteriostatic agent to put microbes to sleep. This delicate balance can extend shelf life up to 10 days without chemical preservatives. Another exciting area is active packaging. Packaging is no longer a passive protector. Ethylene scavengers, usually potassium permanganate based, placed inside the packaging absorb ethylene, the aging hormone of fruits. You must use this technology so that a crate of apples in your warehouse does not rot to kiwis next to it. This is engineering, knowing the rules of nature and turning them to our advantage. Thermodynamics is for giving friends to range between 10 degrees Celsius and 63 degrees Celsius, which we call the danger zone for bacteria. It's essentially a breathing paradise. If you leave cooked food to cool down at room temperature, you are sending an open buffet invitation to bacteria. This is where the blast chiller come into play. These devices are not a luxury, they are a necessity of HACCP protocols. The rule is very clear. You have exactly 90 minutes to reduce the core temperature of a cooked food from 70 degrees Celsius to 3 degrees Celsius. If you try to do this in a standard refrigerator, you will raise the internal temperature of the fridge, spoil other products, and fail to cool the food in time. The blast chiller handles this task by increasing the heat transfer coefficient with high-speed airflow. What does this have to do with waste? It's simple. With the cook chill method, you can, for example, make 500 portions of lasagna on Monday, shock freeze them, and keep them fresh until Friday. This minimizes the stress of how many customers will come today and the risk of dumping unsold food. Surplus production becomes ready stock, not waste, and speed is our greatest ally in food safety. There is a lie that has been memorized in warehouse management for years. First in, first out. If you are selling bricks or cement, this is a great method, but if you are selling lettuce, strawberries, or fresh fish, first in, first out can mislead you, because strawberries that arrive on Thursday might spoil faster than strawberries that arrive on Monday, depending on harvest conditions and transport temperature. Therefore, our new standard in food engineering is first expired, first out. This principle focuses not on when the product entered the warehouse, but when it will die. Tracking this manually is hard, I admit. However, warehouse management systems and RFID tags come to our rescue here. The digital system gives a red alert to the chef for products nearing their expiration date. Looking at this data, the chef creates an instant daily special on the menu. For instance, are the mushrooms losing shelf life? A discounted cream of mushroom soup immediately appears on the menu. This is proactive, not reactive. Inventory management. It's the art of catching waste before it happens and turning into cash. Here we come to the metrics part of the business. For years, waste in kitchens was tracked like someone wrote, "We throw away a lot of tomatoes today," on a piece of paper. You cannot manage anything with this data. As management guru Peter Rucker says, you cannot manage what you don't measure. Technologies like Winnow Vision and LandPath turn your trash can into the world's smartest scale. When a staff member dumped a tray into the trash, the camera captured the image. Artificial intelligence recognizes it as half portion rice. The scale measures the amount and the system calculates the cost, all within seconds. What does this data tell you? Your chef can look at the report and see every Thursday 5 kilos of mashed potatoes returned from the buffet. This means the demand for potatoes is low on Thursday. Then the production per level must be adjusted and 5 kilos less potatoes should be boiled on Thursday. In businesses using the system, we see a 2 to 8% decrease in food purchasing costs and a 50% reduction in waste. This is the most concrete example of return of investment for AI in the kitchen. In food safety, blockchain is a digitized form of trust. It's the immutable recording of data, which day a lettuce has harvested from the field, at what temperature it was transported in which truck, and when it entered the shelf. The most critical engineering application here is smart contracts. Imagine you have a truck carrying frozen fish. To IoT sensor in the truck detect that the temperature rose above -18 degrees Celsius. Cold chain broken. The smart contract instantly writes this to the blockchain and automatically warns the buyer, even stopping the payment. Why it's important? Because it prevents spoiled products from entering your warehouse instead of that product entering the shelf, poisoning the customer, and then creating a mass disposal and brand crisis. The problem is detected at the door or even on the road. Applications like the Ministry of Agriculture and Forestries and deposit management system in Turkey are the first steps of this digital traceability infrastructure established by the state. Menu planning is not just listing delicious dishes one after another. It's a game of data science and psychology. I want to mention two concepts here: yield testing and nudge theory. The first is a mathematical fact. When you buy 10 kilos of fish, you don't have 10 kilos left after cleaning. Bone, heads, maybe 6 kilos remain. If you calculate your cost and portion based on the as purchased weight, you will go bankrupt. My engineering is calculating how to use that 6 kilos most efficiently. The second is human psychology. Nudge theory is about guiding people to make the right decision through environmental cues without imposing bans. Study in buffets show that reducing the plate diameter by just 3 centimeters reduces the amount of people take by 20%. Because our eyes want to see the plate full, shrink the plate, satisfy the eyes, satisfy the stomach, but don't let food go to the trash. Also, trayless dining dramatically reduces waste by ensuring people take only what they can carry. What are the countries that have solved this problem doing? We can see again three different approaches: stick, carrot, and education. France chose the stick with the Loi Garou law. It's told supermarkets you cannot throw away edible food, you cannot pour bleach or in it to destroy it. You must donate it or you will be fined. This was a first in the world and caused an explosion in food banking. Italy, our Mediterranean neighbor, chose the carrot with the Gatta law. It told businesses, if you donate, I will reduce your bureaucracy and give you a discount on your waste tax. Italians understand incentives, not punishment. This model includes businesses in the system voluntarily. Sweden focused on education and data. They use a simple but brilliant method called testing spoon in school meals. The students test the food before taking it. If they like it, they take it. They don't take food they don't like and throw it away. A simple behavioral change prevents tons of waste. As Turkey, we need a hybrid version of these three models. Beyond legislation, let's look at countries using the power of technology and civil society. Denmark is the poster child of Europe in this regard. The Stop Wasting Food movement, initiated by Selena Jewel and the Danish origin app Too Good To Go, turned the event from a waste problem into an opportunity to hunt. Customers buy product leftover at restaurant closing times very cheaply. Both the business wins and the consumer gets fed. The Netherlands is becoming a giant in logistics and AI. A startup called OneThird developed an AI scanner that scans products like avocados or strawberries The scanner looks at the internal structure of the fruit and can say the strawberry will spoil in 2 days, put it on the shelf immediately, or this avocado will last another 5 days, send it to the distant market. Dynamic routing is the supply chain. Germany, with its national strategy So gut für die Tonne, invest in smart packaging. They are developing technologies that show food spoilage with color-changing labels, not just relying on the expiration date. In the other word, Germans are on the R&D side of the business as always. So what are we doing? We are much better than you think. Turkey is a dynamic market with high digital adaptation. Hilton Turkey's Green Ramadan project is a case we are proud of. We know that vast increase in iftar buffets during Ramadan between 25 to 50%. Hilton installed the Winnow AI system and analyzed which foods went to trash. Chefs made decisions with data such as this pastry is left over a lot, let's reduce the portion, or let's simplify the dessert buffet a bit. Result a massive decrease in both waste and carbon footprint. Another hero is the local startup Fazla. Their collaboration with Divan Group is the digitalization of waste management. They not only measure waste, but also direct unsellable products to food banks and convert them into animal feed as a last resort. The most concrete example of the circular economy in Turkey. This project shows that Turkey has both the technology and the will. Dear guest, I conclude my presentation. I want to paint a picture of the kitchen of the future for you. In this kitchen, chefs don't just use knives, they read data from tablets, trash cans talk, refrigerators warn you. Our roadmap consists of 4 words: measure, engineer, optimize, transform. If you don't measure, you won't know. If you don't use engineering, you can't protect. If you don't optimize with data, you remain inefficient. And if you don't transform, you consume the future. The year 2025 will be a breaking point. Gap cost will increase. Inspections will tighten. Those who make these investments today will not only escape fines tomorrow, but will also gain a competitive advantage in the market. Remember, the cheapest food is the food you don't throw away. Thank you for listening.